Look up at the night sky and find the constellation Orion. On the upper left corner, you'll see a bright red star. That's Betelgeuse. Betelgeuse is a red supergiant, one of the largest stars we can see with our naked eyes. It sits about 650 light-years away from Earth, which in cosmic terms makes it our neighbor. On a clear night, it's one of the 10 brightest stars in the sky. But Betelgeuse is dying. This star has reached the end of its life. Its core is running out of fuel. At any moment, tomorrow, next year, or 100,000 years from now, it will explode in a supernova. When it does, it will become one of the brightest objects in our sky, visible even during the day. The explosion might have already happened. Light takes 650 years to reach us from Betelgeuse. The star you see tonight shows you what Betelgeuse looked like in the 1300s. If it exploded yesterday, we won't know for another 6.5 centuries. But when that light finally reaches Earth, everything changes. The explosion will be visible across the entire planet, transforming our night sky and giving scientists the opportunity of a lifetime. Betelgeuse is not a normal star, it's a monster. If you could place Betelgeuse where our Sun is, it would extend past the orbit of Mars. Some measurements suggest it might reach all the way to Jupiter. The star is roughly 700 times wider than our Sun. Earth would be inside it, vaporized instantly, along with Mercury, Venus, and Mars. This size is a sign of death. Stars don't start out this large. Betelgeuse was born about 10 million years ago as a massive blue star, perhaps 20 times heavier than our Sun. It burned through its hydrogen fuel quickly, the way all massive stars do. When the hydrogen ran out, the star began fusing helium, then carbon, then heavier and heavier elements. Each new fuel source burns faster than the last. The star expanded as it aged, cooling from blue to red as its outer layers spread into space. Now Betelgeuse is fusing silicon in its core, creating iron. This is the final stage. Iron fusion consumes energy instead of releasing it. When the core becomes iron, fusion stops. The star has nothing left to hold itself up against gravity. At that point, collapse is instant. Betelgeuse has been showing strange behavior recently. In late 2019, the star dimmed dramatically. It lost more than half its brightness over a few months. Astronomers watch closely, wondering if this was the beginning of the end. It wasn't. By early 2020, Betelgeuse returned to normal brightness. Scientists now think the dimming was caused by a massive dust cloud ejected from the star's surface. The dust blocked our view temporarily, like smoke obscuring a fire. But the event revealed something important. Betelgeuse is unstable. The star pulses and throbs, throwing off material as its core struggles to maintain balance. These are the death throes of a supergiant. The star could explode tomorrow. It could explode in 100,000 years. On cosmic timescales, both time frames are essentially the same, imminent. And there's another possibility that keeps astronomers awake at night. The explosion might have already happened. Right now, at this moment, a wave of light from Betelgeuse's death could be racing toward Earth. It might arrive next week. It might arrive in 500 years. We have no way of knowing until the light reaches us. For now, Betelgeuse still shines in Orion's shoulder, but that could change at any moment. The explosion begins in silence. Deep inside Betelgeuse's core, iron accumulates. Unlike lighter elements, iron doesn't release energy when it fuses. It absorbs energy. The core becomes a ball of iron, roughly the size of Earth, sitting at the center of a star, hundreds of times wider than our Sun. For a brief moment, nothing holds the core up. Gravity wins. The core collapses in less than a second. Material falls inward at a quarter of the speed of light. In that second, the core compresses from the size of Earth to the size of a city. Electrons are crushed into protons, forming neutrons. The collapsing core becomes so dense that atomic matter can't exist anymore. Then it rebounds. The collapse stops when the core reaches nuclear density, the same density as an atomic nucleus. The infalling material hits this incompressible wall and bounces back. A shock wave races outward through the star at thousands of kilometers per second. When it reaches the surface, Betelgeuse explodes. The explosion releases more energy in a few seconds than our Sun will produce in its entire 10 billion year lifetime. The light from this explosion will take months to reach its peak brightness, but when it does, Betelgeuse will become extraordinary. At its brightest, the supernova will shine with the light of 100 million suns. From Earth, 650 light-years away, it will appear brighter than the full moon. You'll be able to read a book by its light at midnight. It will cast shadows on the ground. During the day, Betelgeuse will be visible as a bright point in the sky, easily seen without any equipment. For weeks, possibly months, we'll have a second bright object in our daytime sky. Children will point at it. Planes will fly beneath it. It will be impossible to ignore. History has recorded supernova before. In 1054, Chinese astronomers observed a supernova that created the Crab Nebula. It was visible during the day for 23 days. In 1572, Tycho Brahe observed another supernova that outshone Venus. The most recent naked-eye supernova was in 1987, but it occurred in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. It was visible only from the southern hemisphere and never became bright enough to see during daylight. Betelgeuse will be different. It's closer than any of these previous supernovae. It's in a constellation visible from most of Earth. Nearly every human on the planet will be able to witness it. The light show will last for months. After reaching peak brightness, Betelgeuse will slowly fade over the course of a year or more. Even after fading from daytime visibility, it will remain one of the brightest objects in the night sky for months afterward. Eventually, it will dim enough to require telescopes, but the remnant will remain visible for thousands of years, an expanding cloud of gas and dust glowing from the heat of the explosion, slowly cooling as it spreads into space. For one brief moment in human history, we'll witness the death of a star. The explosion sends three things toward Earth, and they arrive in a specific order. First come the neutrinos. These particles are created in enormous numbers during the core collapse. They barely interact with matter, so they pass through the exploding star almost instantly and race toward Earth at nearly the speed of light. Neutrinos will reach us minutes before the light does. Trillions of neutrinos will pass through your body every second for several hours. You won't feel anything. Neutrinos pass through normal matter as if it doesn't exist. Most will travel through Earth and out the other side without hitting a single atom. But sensitive detectors buried deep underground will record them. This neutrino burst will alert astronomers that Betelgeuse has exploded, giving them a few hours warning before the light arrives. Then comes the light. This is what everyone will see, the visible explosion that transforms Betelgeuse from a bright star into something that rivals the moon. The light will reach us about 650 years after the explosion actually occurred. It will arrive as a steady stream of photons across the entire electromagnetic spectrum. Visible light, ultraviolet, X-rays. The radiation sounds dangerous, but at 650 light-years, we're perfectly safe. Earth's atmosphere will absorb most of the harmful ultraviolet and X-ray radiation. The ozone layer might thin slightly, but not enough to cause any real damage. You could stand outside and stare at the supernova without risk. The light is bright, but it's not concentrated enough to harm you. Satellites are a different story. The increased radiation will affect spacecraft in orbit. Communication satellites, GPS systems, and scientific instruments will need to adjust for the higher radiation levels. Space agencies are already planning for this. When Betelgeuse explodes, satellites will enter safe modes, protecting their electronics until the radiation surge passes. The International Space Station will need to take precautions. Astronauts will receive a higher radiation dose during the supernova's peak, though still within safe limits. Mission planners might delay spacewalks during the brightest phase. Months or years after the light arrives, cosmic rays follow. These are high-energy particles, protons and atomic nuclei, accelerated by the supernova shockwave to nearly the speed of light. They will arrive scattered over decades, a slow drizzle of energetic particles rather than a sudden burst. Earth's magnetic field will deflect most of these cosmic rays. Some will reach the upper atmosphere, creating additional radiation. Again, the effect will be minimal. You'll receive more radiation from a cross-country flight than from Betelgeuse's cosmic rays. Scientists will monitor Earth's atmosphere closely. The increased radiation might trigger additional lightning storms or affect cloud formation in subtle ways. The ozone layer will recover quickly from any thinning. Within a few years, Earth's atmosphere will return to normal. The biggest effect will be on our view of the universe. For months, Betelgeuse will outshine everything in the night sky except the moon. Astronomers will struggle to observe anything else in that region of space. The supernova's light will flood their instruments, creating a dead zone where no other objects can be studied. But this inconvenience is a small price to pay for the scientific treasure we'll receive. The data collected during Betelgeuse's explosion will answer questions we've had for decades. We'll watch a supernova unfold in real time, from the first neutrino detection through the peak brightness and into the slow fade. We're safe. We're far enough away that Betelgeuse's death will be beautiful rather than dangerous. We get to watch one of the universe's most violent events from the perfect distance, close enough to see everything, far enough to survive. Nobody knows when Betelgeuse will explode. The star could detonate tomorrow. It could wait another 100,000 years. Both are possible. Both are, in astronomical terms, imminent. Predicting the exact moment a star will explode is beyond our current capabilities. The problem is that we can't see inside the star. We observe the surface, its brightness, its temperature, its pulsations, but the core sits hidden beneath hundreds of millions of kilometers of stellar material. The processes that will trigger the collapse happen deep inside, invisible to our telescopes. We know Betelgeuse is in its final stage of life. We know it's fusing silicon into iron. We know that when the iron core reaches a critical mass, collapse is inevitable. But we don't know how much iron has accumulated. We don't know how close the core is to that critical threshold. We won't know until we see it. That was the end of the video. If you feel interested, please do not forget to like and subscribe for more content like this.